This section of the book looks at the relationship between exponentials and logarithms. For the sake of this video, we'll look at sort of one very important relationship between them, particularly for logarithms. So previously we've talked about logarithms, and in general we'd write something like log base a of b. And oftentimes we want to compute what this actually is for specific numbers a and b, but there's one problem with that, namely it all hinges on what the base is. So when you do this on a calculator, the only two bases that appear on a calculator are base e for the natural logarithm and also usually base 10 for the common logarithm. So if you wanted to compute, for example, something like log base 5 of 72, then you're not going to be able to do it with a calculator unless we can somehow rewrite this. And fortunately, there's a nice way to do it. It's called the change of base law. And it says this: if you've got a logarithm and it's in base a and you're taking the log of b, then choose any base that you want to convert this into, and you can change it by doing the log of b with respect to the new base you choose divided by the log base c of the old base. So the common uses of this is to choose c either equal to e for natural logarithms or 10 for the common logarithms, and sometimes in computer science, in other specialized purposes, you might choose base 2 for this. But for our purposes, since this is what's on most of the calculators, you want to convert most of these into base e or base 10 logarithms. And it actually doesn't matter which one you use unless you're specifically told. They'll both work just as fine. So for example, let's say that we had this question that we had a minute ago. So the log base 5 of 72. Well, I want to convert this into, say, base 10 logarithms, in which case it would just be the log of 72 divided by the log of 5. Or if I did this with the natural logs, it'd be the natural log of 72 divided by the natural log of 5. So either one of these I could then compute with the calculator, and that's it. So it doesn't matter what base you choose here, although frequently for the purposes of calculus the natural logarithm is preferred, although in lots of real-world uses of logarithms it's all base 10. So we can use this to compute something. So let's just take another example, and let's say that I did the log base 2 of 0.015. And so based on what we did before, I could rewrite it in either format using common logs or natural logs, doesn't matter. If I do common logs, then it'll be log of the thing that you were logarithming before divided by the log of the old base. And if I wanted to do this in terms of base e, it would just be natural log of 0.015 divided by natural log of 2. So in the next quick segment, I'll show you how to compute this either with Wolfram Alpha or if you've got a calculator handy. It's pretty easy. So we'll just come back to this just real quick and get an actual decimal approximation for it. Okay, so we're going to compute this real quick with Wolfram Alpha Now, one nice thing about alpha is that it actually can compute regardless of what the base is. So in this case, we could have just typed in exactly what we were asking. So log base 2 of 0.1015, and if we run this, then it'll immediately give us the answer. And one nice thing is that it's actually done the conversion for us. So for example, here it says alternative representation. Here it's expressed it in the log base 10 format. Actually, no, take that back. So Mathematica and Wolfram Alpha are a little bit different. So in advanced mathematics, if you just see log, it actually means log base e, not log base 10. So here, Mathematica has told us that the log base or log of x is the natural logarithm. Now we normally would write that ln. Now for the purposes of this problem, it actually doesn't matter what base you use to convert into, and so we'll actually manually compute this for two different ways, and we'll end up getting the exact same answer. So negative 6.0588 blah 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 is what we're supposed to get, and so let's just do the change of base manually and see that we do in fact get the exact same thing. So for example, we said that we could do this base 10, and so I'll just do log base 10 of, the numerator would be 0.015, and then I want to divide that by log base 10 of 2. And if I do that, then we get the exact same answer, and this is sort of the form that, that we've actually input. So this input form here is useful to make sure that you don't type something silly, that Mathematica, or in this case Alpha, is correctly interpreting what you're telling it, and here it is. And of course we get the same answer. Now if we wanted to do the other way, then we could just type in ln, and again, to Wolfram, log really is base e, so it interprets ln as log, even though that's not the way that we generally write it, so just be careful. But not surprisingly, we end up getting the same answer. Yeah, then we've got a couple other representations here, sort of in similar format, and a bunch of scary stuff that you don't need to worry about.